In lesson one, we're going to talk about how an equation relates to its graph. So we're looking right here, y equals 4x plus 5 look like this on a graph? It's not magic. It doesn't come out of nowhere. This is actually a representation of all the solutions to this equation. These are all the solutions to this equation. What is a solution? A solution is a value we can put in place of a variable, such as x, that makes the equation true. For example, x plus 2 equals 7, then x is 5. 5 is a solution because 5 plus 2 is 7. 7 equals 7. Something that makes the equation true. So something that works in the equation. So if we're looking at y equals 4x plus 5, I can put in any xy point. There's two variables. Any point on this line will make this equation true. Let's look at an example. Here we see the graph of the equation y equals 3x minus 1. So this is, again, the representation of all the solutions to this equation. In order to explore this, let's pick a point on the graph. Let's say 1, 2. That's the point 1, 2. If I plug it into this table here that plots it, and you can see this is the point 1, 2, falls right on the graph. Let's check it. If it's a solution, we should be able to plug it into y equals 3x minus 1. This is the point 1, 2, which means x is 1 and y is 2. So if y is 2, then 2 equals 3 times x, which is 1, minus 1. 2 equals 3 times 1 is 3 minus 1, and 3 minus 1 is 2. 2 equals 2 is a true statement. This is a solution to this equation because the xy value works. Every single point on this line will work. You can find any of them. Let's throw a few more solutions that would work into our table. How about 0, negative 1? That's on the line. How about negative 1, negative 4? That's on the line. How about 1.5 and 3.5? That is right here. It does not have to be an exact point like this. Every single point on this line will work. If I click on this, you see all those crazy numbers in there? As long as it's on the line, that's going to work in my equation. Let's check 1.5 and 3.5. That fell on the line, so let's look at it. 1.5, 3.5 means that y is 3.5. X is 1.5. 1.5 of 3 is 3 plus a half of 3. So half of 3 is 1.5. Plus 3 is 4.5. 3.5 equals 4.5 minus 1, which is 3.5. It works. This is a true statement, so we're good. Let's look at another random point here. How about 2, 1? 2, 1 falls off the line. Let me erase this. 2, 1 falls off the line right here. That means it will not be a solution. Let's just check it to make sure. That means 2, 1, x is 2 and y is 1, so y equals 3 times 2 minus 1. Should be pretty obvious that this isn't going to work. Y equals 6 minus 1, and 1 equals 5. 1 equals 5 is not a true statement. This is not a solution. And you can see it's off the line. If it's on the line, it's a solution. If it's off, then it's not. A solution will work. If you come up with something that does not work, it is not a solution. So if you are asked if any point is a solution to the equation, there's two things you can check. One, you can check if it's on the line. If it's on the line, you know it's a solution because that's what the line is. It's all the solutions. If you don't have the graph or you can't find the point on the graph, go ahead and plug it into the equation because it has to work. If it does work, gives you a true statement, then it is a solution. If it doesn't work, it gives you a false statement like 1 equals 5, then it's not a solution.